Good afternoon, all. Today, myself N.R. Patel, we will have interaction on one of the most important topic, remote sensing data analytics for crop production forecasting. In crop production forecasting, which is required for many informed decision, policy related decision, demand gap analysis, and so on. It is one of the important topic that meet the needs for food security, advanced prediction, forewarning of foods, and many other logistic related issue. But one of the topic today we will discuss fundamental of remote sensing and sensor for agriculture. First of all, remote sensing, which is one of the latest technology that helps users to acquire information about object on the earth without physical contact with it. That means it acts like our eyes. So satellites are generally treated as eye behind head. So it mimics like remote sensing. Our eye mimics like remote sensing. With respect to Indian agriculture, as all of we know, India is a land of agriculture. It contributes to the rich cultural diversity and helps to earn livelihood for the rural India. More than 60-70% as of now depends on agriculture for their livelihood. Over the past decades, Indian agriculture has been transformed and achieved greater socio-environmental change due to liberalization, globalization, and recently it is transforming to the digital agriculture. Today, with the efforts of government and Prime Minister, now agriculture is transforming digitally in all aspects, including food, livestock, dairy sector, and so on. Agriculture is also central to the sustainable development goal. It does not only add to the economy of any nation, but it also linked to the other aspect like environmental security, water security, and energy security. As you know, agriculture in past, before 2-3 decades, it was supposed to be the major sector contributing gross domestic output in India. It was about 35%. It has declined, of course, to almost less than 20%. It is around 18 to 20% as of now. It's contribute to the gross domestic output, but still it engages larger mass of people and feed them. So it provides larger employment opportunity. You see, agriculture is okay in India. It has tremendous potential. We have food grain production more than touching 320 million tons. Horticulture also more than 350 million tons as of now. We have expanded irrigated area in India almost up to 50%. So employment opportunity also it is creating more than 55%. So all this helping India to grow and revolutionizing agriculture to meet the food consumption requirement as well as our economic development. But when we talk about remote sensing, average field size in India is little bit lesser, as well as average land holding is around 1.15 hectare and field size is around 1/4, means 0.25 hectare. This is a little bit lesser size to apply large scale remote sensing, even though India and mainly the Indian Space Research Organization has made concerted effort to develop majority of remote sensing based application in agriculture. So today, if I can say, it is not wrong that more than 70% of application which are realized today with the help of space technology is only for agriculture sector. So there is a large opportunity already is there and exist, and it will create more opportunity in the future with the evolution of geospatial technology, mainly space technology. Here you see diversity of Indian agriculture. India is a big country with a large diversity with respect to the climate regime. Mainly you can say annual rainfall. Then there are different kind of soil types: alluvial plain, lateritic soil, red soil. We have also many kinds of physiographic setting that ranges from mountain, alluvial plain, coastal area, desertic area, and also peninsula. So if you see large diversity in soil types, climate regime, and physiography, this all poses bigger challenge to make or adopt remote sensing technology for such a big country. Even cropping system, if you see different kind of crops which are grown across length and breadth of India, they are different permeate based. In Dehradun and you can say Western UP sugar cane based system, Punjab Haryana rice wheat based system. There are different kind of cropping system practice. So this all large diversity is there, and it is requiring concerted and systematic effort to expand use of space technology for real time monitoring of agriculture. So fundamentally it has evolved like anything for achieving sustainable agriculture in India. So this geospatial technology, that is not mainly comprising satellite remote sensing along with the GIS and GPS technology. If I can say, sustainability of any country, that depends mainly on the how best we can manage natural resources. In our country, if we want to achieve better management of natural resources, then we need to have better specific system, disseminate specific system of management of crops, input and natural resources to sustain high productivity and ensure profit maximization while curbing any effect on the natural fragile ecosystem. So means we have to develop a precision kind of agriculture where we can maximize profit as well as reduce environmental effect. Modern technology like satellite remote sensing, geographic information technology, communication technology, IoT based sensing, ground network, and many artificial intelligence and so on. These all technology are now making a way for adoption in agriculture system to make better sustainable agriculture plan and bringing all this wasteland and also make better management of natural resource to meet the requirement of agriculture. Satellite remote sensing is nothing but acquiring information about object, as I said. So satellite remote sensing has got certain advantage. It has got synoptic coverage. Large area you can monitor with the satellites. Today we have many traditional conventional survey based system for agriculture. It requires huge manpower, time consuming and expensive. But satellite remote sensing that curtail all this nature resource requirement and make possible to monitor agriculture faster with the large area coverage. Satellites provide multispectral information, partial information. Here partial means distributed across whole area. Maybe it is a state, district or a country. So you can assess crop water requirement, what are the different kind of crop practice across the area, what is the production of different crops across different district and state, that too with the satellite remote sensing. So in this particular course we are mainly focusing on how best we can use satellite based technology to make forecasting of agriculture production. So there is also another tool which is called geographic information system. It is nothing but data management tool which allows you to input, store, analyze partial and non-partial data. Partial means imagery, satellite imagery, any maps which are referenced with certain geographical coordinate. And non-partial data means any point scale observation like soil moisture observation, some crop cutting experiment, some automatic weather station location. So we can use this weather observation, crop cutting observation along with the satellite remote sensing for making certain usable product which are driving different informed decision related to the agriculture sector. So these are the different technology where GPS, which is nothing but location based services. It provides accurate location of particular object or farm equipment on the ground. Mainly in precision agriculture, it has got tremendous role. It provides locational position of a farm equipment, particularly variable rate technology. Another is a GIS, spatial data analytics, which allows, as I said, GIS has ability to integrate data and analyze and display both partial and non-partial data. But nowadays there are mobile based GPS, GIS, there are certain cloud. Now there are different kind of network of server, GIS based server, which are interconnected to develop, make faster processing of data and direct automated decision making of particular aspect on agriculture, like irrigation, smart fertilization, all nowadays this kind of decision, even monitoring, early warning for the drought, food, that is possible to do across whole nation or continent with the cloud based analysis. Earth observation, that is nothing but with the observing earth without having material contact with the earth surface by satellite remote sensing, air based imaging or UAV, unmanned aerial vehicle. So there this all provides suitable measure for how best we can observe earth and interpret those satellite imagery for better assessment of crop condition, crop output and also crop performance. Then scanning, third is a 3D scanning. Nowadays there are many technology available. You can make model with the 3D models, 3D scanning. So LIDAR, some laser based scanning, and radar. Radar means which uses its own illuminating source. There are radar technology which is also exist in case of weather monitoring like Doppler radar. So which doesn't have its own use natural light, but it uses its own source of illumination, and any backscatter signal is being recorded by the sensor, those called radar. So here you can see geospatial technology which covers earth observation, GIS, GPS. A synergy of these three technologies must required if you want to make use of this geospatial technology for informed decision making on aspect of water management, nutrient management, crop planning or any early warning for the production like crop production forecasting. We need to have a integration of three technology: GPS, GIS and satellite remote sensing. So what is remote sensing? It is a science or it is a technique that helps you to obtain information about object on the earth's surface without having physical contact. In another, satellite remote sensing, we can say it is using satellite with some sensor on board which collect information about the earth. Here you can say sun is the source of light, natural light. We all receive natural light from the sun. This sunlight is either absorbed, transmitted or reflected. Those reflected energy is being recorded by the satellite sensor on the satellite, which is called passive remote sensing. If there are satellites which use its own light for illuminating target on the ground, those are called radar. So and receive backscatter radiation as a backscatter coefficient. So this is called synthetic aperture radar, SAR basic image analytics. So there are different kind of remote sensing, active and passive kind of remote sensing. Active remote sensing means radar, scatterometer. Passive means optical remote sensing, thermal remote sensing. We will go into detail in the later slide. Now you see, passive remote sensing means it uses natural light which is either reflected or emitted by the earth atmosphere. So sensor which are in the onboard satellite have ability to detect this reflected or emitted radiation. Reflected means sun rays which are reflected from the different feature. Like okay, we know in vegetation there is a chlorophyll, water content, different kind of cell structure, and so on. So particular sun rays wavelength with the varying wavelength interact with the vegetation, and based on the composition of the leaf like chlorophyll concentration, water content or canopy structure as well as canopy cover, it helps it reflect different amount of energy. So if chlorophyll concentration is more, it reflect lesser in case of visible light, because visible light mainly you can say green, blue and red, which is mainly utilized for the photosynthesis process. So this visible light is also called photosynthetically active radiation, PAR. So it is hardly 7 to 8% of this light is being reflected from the vegetation, because it is mostly absorbed for the photosynthesis. But in the near infrared range it gets scattered, particular this near infrared wavelength which gets scattered from the vegetation. So this is a passive remote sensing where reflectors is either in visible, near infrared or short wave infrared, which is recorded by the satellite sensor, and those satellite sensor are Landsat, our resource set LIS 3, LIS 4, Terra MODIS and Sentinel 2, and then also there is a MODIS, GPM, global precision measurement, and GRACE, the gravity based satellite. That these all are passive remote sensing. Then we go to active remote sensing, when sensor uses its own source of energy to illuminate target, and backscatter signal is being recorded as a backscattering coefficient. So that is called active remote sensing. Now passive remote sensing is just like our camera without flash, and active remote sensing means camera with flash. That is simple thing. So particularly microwave region, this active remote sensing operate in microwave region, and it record the backscatter microwave energy by the sensor. So there are different kind of active microwave remote sensing sensor. They are called radar, so synthetic aperture radar. So we have in India one satellite called RISAT. Then there are other satellite, Sentinel 1, RadarSat. These are the all active remote sensing satellite. Then here you try to understand different kind of satellite based imaging technology. One is a multispectral remote sensing. Multispectral means those sensor on satellite which are having few discrete and widely spaced spectral bands, and you are allowing use for the detecting crop vigor, vegetation health and so on. So they are useful for crop type mapping, monitoring crop condition and also stress with the few band. Maybe okay, you can say 4 to 8, 9, those kind of bands. Landsat, LIS 3, ResourceSat, those are all multispectral imaging sensor. Another is a thermal remote sensing. Thermal remote sensing means this is a type of remote sensing which measures surface temperature of the earth. That means thermal means what, that thermal signal, that means surface temperature. So any temperature signal in terms of thermal emission from the surface is being detected by certain sensor called thermal imaging sensor. So they provides canopy temperature of the crops, and that canopy temperature is ideally suited to detect crop stress, particularly drought and pest disease. Another sensor is a lidar. Lidar, they are the light detection imaging radar, light detection ranging radar, ranging technique. So which uses pulse, laser pulse to create 3D maps of the crop canopy. It send pulse and receive back scatter pulse signal at the top of the target and from the bottom of the target. So by taking a phase difference, one can measure height of a particular object. So if we can able to make height of the canopy, then we can easily estimate crop biomass. This is very much useful, particularly in agriculture, for measuring biomass of high biomass crop like sugarcane, maize, agroforestry, those kind of agriculture system. We can better measure or quantify biomass of a crop to make better assessment of the carbon footprint or carbon sequestration. Radar imagery. Radar it can penetrate through clouds. So these radar are having unique characteristic. Those radar are independent of weather condition. They can penetrate through clouds and provide you information about the surface. So it enters into the vegetation and give you information about soil moisture. It enters into the vegetation and give you information about different branches, petioles and biomass. So that is why it is very much useful. Radars are very much useful for detection of soil moisture, crop growth health, crop growth beneath the surface, and any understory that also can be monitored. And now here you can try to understand what is reflectors. Reflectors means amount of energy which is reflected from the surface. Here in our case it is a crop. Amount of energy reflected from the crop canopy surface divided by amount of energy which is impinging on the canopy surface in a particular wavelength. So wavelength, suppose it is a visible wavelength. So amount of energy reflected in the visible wavelength divided by amount of energy, sunlight energy in the visible range impinging on the canopy surface, multiply by 100, that gives you a spectral reflectance. So here you can see in from 0.4 to 0.4 to 0.7, that is a visible range or visible light which is highly absorbed by the crop canopy for photosynthesis. Then after up to you can say 1.1, from 0.7 to 1.1, that is a near infrared. That is a near infrared which is highly scattered or which is highly reflected in the healthy crop canopy, because whenever healthy cell wall is there, a cell wall interface, more multiple scattering of the near infrared wavelength happen. So if healthy cell wall, better cell wall interface is there, so more multiple scattering, so reflectance will be more. Then you go further, there are 1.4, 1.9 and 2.4. There are 3 water absorption band. These are water absorption band with respect to the short wave infrared range. So short wave infrared wavelength at this particular wavelength range is being absorbed by the plant canopy, because plant has got leaf water content, leaf water potential. If more water potential, liquid water thickness is more, so it has ability to absorb more short wave infrared radiation. Then comes to the soil. In case of soil, both visible and near infrared. Almost you will find here, okay, little bit, but almost if pure soil is there, you will find almost both near infrared and red reflectance is zero, almost equal. Now you see how we can detect different kind of surface with the satellite based spectral signature. Now here you can see vegetation, that green. In the visible range, majority of this it is absorbed. So you will find reflectance less than 10, 5 to 10% in the red, green, blue, green and red. Then after sharp rise in the near infrared range, because of cell wall structure, good cell wall structure, so more multiple scattering. But in soil, mostly it is equal. In ocean, in case of near infrared, most of this near infrared wavelength is being absorbed in the water, open water. So it appears dark in the FCC. So different kind of interaction, reflectance of different feature, whether open water bodies, snow cover or vegetation or soil, interact differently and reflect different amount of energy. Depending upon the different reflectance across electromagnetic radiation helps you to differentiate these different feature or surfaces in the satellite imagery. Now let us understand passive microwave remote sensing. We have understood passive optical and active microwave. Now passive microwave. Passive microwave means microwave energy itself is a very weak energy. So passive microwave energy sensor detect naturally emitted light within the field of view. Which is natural light? One is sunlight, which is received from the sun, and emitted light means emittance, which is happening mainly from the earth. Earth emit radiation at the surface in proportional to the fourth power of its absolute temperature in the thermal range. But in the microwave range also it emit radiation depending upon the dielectric constant and reflectivity. So because this passive microwave wavelength are very longer wavelength, it is around 5.6 gigahertz, 37 gigahertz or 89 gigahertz. So it is very longer wavelength and very low frequency. So when low frequency is there, its energy content is very less. So there is always a inverse relationship between energy content and wavelength. So if less energy content, it is not easily detectable by the satellite sensor. So to make it possible to detect this weak signal from the surface, it is required to have a larger instantaneous field of view. So partial resolution, or you can say camera view, instantaneous field of view should be very large. That is why this majority of passive microwave sensor has got partial resolution to the order of 25 kilometer to 30 kilometer. But their frequent repeat cycle is almost daily or once in a 2 day. So there are many sensors available which are operating in the passive microwave sensor and enabling us to acquire information about the soil moisture. Today, majority of soil moisture product database available globally and publicly free, they are mainly developed from passive microwave satellite sensor. Whether it is a MSR2, soil moisture active passive sensor, so SMOS, soil moisture observing mission, all these, whether NASA or other space agency, they have slated different mission in the past in microwave energy. They are ideally suited for giving rainfall estimation as well as soil moisture estimation on a almost daily time step. Another is a active microwave. Active microwave means it uses its own illuminating source and detect or measure a radiation or signal which is backscattered after interacting with their target. So radar, they are mainly little bit high partial resolution sensor. They have the ability to detect signal, so they can penetrate through the cloud, they can penetrate through the vegetation, and have ability to acquire information about the understory vegetation also. That is why this kind of active microwave remote sensing sensor, they are ideally suited for the soil moisture estimation and as well as biomass and other complex canopy structure. But it can be made useful for agriculture, mainly soil moisture, when we are having a constellation of satellites. So because soil moisture is required almost on a daily time step. So with the high partial resolution, it is highly not possible to get the image with the radar kind of satellites on a daily basis. But it can be possible to have a radar imagery on a weekly basis, and we can get some sort of signal related to the soil moisture, but through downscaling. Now here try to understand how different kind of satellite image characteristic, that is partial resolution, spectral resolution, radiometric resolution and temporal resolution. Partial resolution means ability of a satellite sensor to resolve minimum area on the ground. That means ability of sensor to distinguish to close feature on the ground. Resolution depends on the satellite orbit or institutional field of view. So different sensors have different partial resolution, signifying ground surface area that forms 1 pixel on the image. Means what is the minimum ground area representing one particular 1 pixel size in the image. So there we are having our satellite like resource set 1 and 2, which is having 3 sensor, PAN sensor, LIS 4 sensor, LIS 3 and advanced sweeps. So LIS 4 having 5.8 resolution meter resolution, LIS 3 having 23.5 meter resolution, and advanced sweeps having 58 meter resolution. So the different resolution. So LIS 4 you can detect even some agroforestry system. You can use also for some biomass estimation of the age and many other orchard crop mapping. Small means field size, small field size, or for field boundary detection also. But LIS 3 mainly useful for the 23.5 meter resolution, which is mainly useful for the crop type mapping. Here I am showing some 1 meter resolution, 10 meter and 30 meter. You see 30 meter you cannot see all roads, but here you are seeing able to see all roads, and in 1 meter you distinct features you can see on the ground. Similarly, spectral resolution, ability of sensor to detect small difference in the wavelength or representing number of spectral band a sensor is carrying on the satellite platform. So there are satellites like Landsat, which is having 8 to 10 spectral bands. We are having LIS 4, which is having 3 bands, LIS 3 4 bands. So there are different multispectral imagery, and Sentinel is there also, which are having 7 to 8 bands. That is called spectral resolution. So more number of bands, better you can categorize diagnostic spectral reflectance and absorption feature of the particular object. That is why hyperspectral remote sensing, which is having more continuous narrow band, more than 200 spectral bands, which allows you to represent or which allows you to detect smallest difference in the reflectance or confusive species, plant species, confusive growth stage, or you can say varieties. But the same cannot be possible with the multispectral remote sensing. Then third is the radiometric resolution. Radiometric resolution is a measure of sensor ability to differentiate small difference in the magnitude of radiation intensity from ground area. That means it represents the number of gray level within for particular sensor it is measuring in more number of 8 bit data, that means 0 to 255 gray level. Total gray level are 256. So it is dividing different feature which are closely related or distinguished. Different feature can be lesser distinguished compared to the those data which are having 10 bit, that means more than 1054, so 56. So those having high bit data, higher bit, then that is radiometric resolution is good, so you can have a better quality satellite image. Fourth is a temporal resolution, that means ability of sensor to make observation of particular area at regular interval, or you can acquire ability of sensor to acquire image of same area on regular interval, that means daily, weekly, 23 days or 24 days. So like LIS 3 which is having 23 days 23.5 meter resolution, but 22 days repeat, every 22 days it will come on the same area and acquire satellite image. But we have another Sentinel 2 which is every weekly you can get same area. Then there are also satellite like Modi's, daily you can get same kind of image but coarse resolution, but daily over the whole large area. So there are different kind of temporal revisit time of different sensor, but this temporal resolution is very key for monitoring agriculture. So whenever we are talking about monitoring agriculture, crop growth stage, crop condition, agriculture drought monitoring, or you can say phenology monitoring, all those aspects require high temporal resolution or frequent revisit cycle less than week. Then only we can able to monitor agriculture with the quite good accuracy, and also we can use those data for certain regulating farm operation. So there are feature of data. This different feature of remote sensing data is there. One already I told, multispectral observation, which allows crop discrimination and crop growth assessment. When multispectral means few bands, discrete and widely spaced band, they are useful for identifying different kind of crop as well as crop growth monitoring. Satellite also has got large area coverage. Synoptic means it can enables you to cover large area, maybe whole district or whole state with the single date. So you can cover assess large area for crop monitoring, like agriculture drought. Drought is not a local phenomena. Agriculture drought is a regional phenomena. You need to monitor whole state or whole region on a daily time step or weekly time step. There you require large synoptic coverage with the frequent revisit cycle, like temporal resolution of lesser than week, so that you can monitor a whole region drought with and make certain informed decision and contingency measure or intervention for better crop assessment, and also some advisory related to the combating drought. Multi-temporal, that means all I said, multi-temporal or temporal means frequent revisit cycle. There are certain satellite sensor which like advanced sweeps, our resource set 1, 2, which is having a advanced sweep sensor which has got every 5-day repeat cycle. So every 5 day you can have ability to measure same area and assess crop condition, crop growth stage and other things. So that is a revisit cycle is quite important, because agriculture is a dynamic phenomena. Crop growth, crop monitoring, crop condition, it is a dynamic phenomena, it's changing every weekly. So you need to monitor this kind of aspect of agriculture sector almost daily or weekly time scale. Multiple utility, same data, because satellite data which are available It is not like that it is useful only for agriculture. Same data we can use for geological mapping, same data we may use for soil mapping, water resource assessment, same data can also be used for coastal zone management and so on. So same data has got many kind of application. So we can reduce the cost aspect, and also we can have same land use land cover we can generate also water body map, we can generate also slope and aspect map and so on. Full data archive and reanalysis capability also. These satellite data which can be archived in the historical archive can be made and stored in the particular server or you can cloud. So we can make use of this data after 25 years and analyze with respect to the climate change signal. These days there is NOAA HR. There is one satellite by the NOAA which was launched in 1981. It has generated more than 35 years of greenness index data from satellite. So there, those 35 years of archive of vegetation index, nowadays it is becoming a asset for analyzing climate change signal. So this satellite data, if it run continuity in a continuity, would help to fight and generate best as a climate product for assessing climate change signal. So there are multispectral sensor, different kind of sensor which are useful for agriculture. So multiple sensor, multispectral, they are Landsat, Indian remote sensing satellite like ResourceSat 1 and 2, Sentinel 2. These all satellite provide multispectral imagery for agriculture research as well as agriculture monitoring. Hyperspectral sensor. Today we do not have globally, you can say, as such high resolution hyperspectral sensor, but there is a sensor is there, Proba, and then we had 2 years back there was a sensor called Hyperion by NASA. That was hyperspectral sensor. Hyperspectral means it is having a more continuous narrow band, having ability to detect smallest diagnostic reflectance and absorption feature, and have ability to detect different kind of confusing species, plant species, plant growth stage, different kind of causes of stress and so on. Because as on today, as I said, multispectral remote sensing can help you to detect crop stress, or you can say crop anomaly, whether crop is bad or good or worst, that you can say with the multispectral remote sensing with the few widely spaced band. But you cannot say a crop is having a stress due to nutrient, water, heat stress, pest disease stress or so on. You cannot ascertain causes of stress with the multispectral remote sensing. There you require hyperspectral remote sensing. That is why for management purpose, agriculture management or crop management, prescription remote sensing, we need hyperspectral remote sensing satellite which helps us to identify causes of different stress, and accordingly we can recommend our farmers to go for certain specific kind of management to fight against pest, disease, heat or nutrient stress. Another sensor is SAR. SAR sensor can penetrate through clouds and work in all weather conditions. They are useful for monitoring soil moisture, flood mapping, crop height. For example, RadarSat, Indian satellite, recently we have launched, ISRO has launched EOS 4 and ReSat 2A. So EOS 4, that is the Earth observing satellite which is providing imagery during cloudy condition and helping in a different mode, fine mode or medium mode. You are getting high resolution to the coarse resolution satellite imagery from this radar satellite, and it is helping to map not only rice area but it also now making potential for assessing high biomass crop like sugar cane, pearl millet, jowar and other crops. Thermal sensor, This sensor which measure mainly the thermal emission and also quantify it into a canopy temperature. So this canopy temperature helps in assessing crop water stress. When we want to assess crop water stress, whenever there is a crop water stress, what will happen? Crop water stress means less amount of evapotranspiration is happening. If more evapotranspiration, it leads to the cooling of surface because it is extract losing energy. When any system, plant system or any system losing energy, it leads to the cooling of the surface. So when evapotranspiration occurs, it loses energy, so it cools the canopy surface. But when crop is under stress, it restricts evapotranspiration. Evapotranspiration will be reduced. As a result, canopy temperature goes up. It warms canopy surface. As a result, canopy temperature goes up and it can be used as a signal for water stress detection. So canopy temperature minus air temperature, which is called canopy air temperature differential, which is useful for detecting crop water stress. So this particular sensor has got wide range of application in other area also, but in agriculture mainly crop water stress detection, this evapotranspiration mapping, to some extent okay we can assess irrigation needs, and people also can able to do generate air temperature also. If we have course resolution on daily time step, we can also extend it through certain technique to map and monitor air temperature. LIDAR, light detection and ranging, which is technology used to create 3D map of agricultural landscape, like agroforestry. If it is agroforestry, what is the main aim of agroforestry? We are improving land equivalent ratio. We wanted to generate benefit of more income, restore soil fertility, improve carbon sequestration, and we get food, fodder and fiber. So there are diverse kind of use of agroforestry system, and it is a versatile agriculture farming system which helps not only to enhance farmer income, but also it helps to fight against the climate change through mitigation option. So those kind of agroforestry map, if you want to generate 3D of which are some different kind of orchard, mango orchard along with the wheat crop, those agroforestry with the different understory, and this we can generate 3D map and we can get better estimate of the biomass of orchard as well as crop underneath. Then biomass of crop like maize and sugar cane also we can high biomass crop also we can be possible to measure with the LIDAR. These are the certain satellites with resources 1, 2, which are having currently operated by the Indian Space Research Organization, and also we are having a SAR sensor reset EOS 4, and we are having OceanSat, which is also carrying one sensor called Ocean Color Monitor. Ocean Color Monitor, it is really designed for mapping phytoplankton concentration or ocean color, but it has got diversified use for agriculture, like it provides vegetation index, so which is useful for monitoring agriculture drought and crop condition. Globally, there are wide range of satellites available with the different resolution. We can talk about monitoring satellite. Those are monitoring satellite which has got coarse resolution less than 100, means 100 and more, like Terra Modis, advanced sweeps or proba or many other satellites which provide daily time scale imagery, but they are mainly monitoring, useful for monitoring with the coarser partial resolution. So they can be useful for monitoring agriculture ecosystem at regional scale. But there are satellites like Landsat 8 which are having spatial resolution within the order of 30 to 100. So these are the satellite having poor repeat cycle, 16 days or 24 days. So these can be useful for mapping. They are largely we can define as a mapping satellite and monitor landscape to regional scale. They are not ideally suited for monitoring, but they are majority, we can say it is a mapping satellite for geological mapping, soil mapping, crop mapping, and so on. Then there are certain satellite globally, spot series with the Sentinel and also Sentinel 2A and B. All there are constellation of two or satellites. So one or two satellite or constellation come with result into combined revisit cycle of 1 week time. So these are the satellite providing satellite imagery every weekly. So they are ideally suited for monitoring also, like drought monitoring, crop condition monitoring, crop phenology monitoring, but not for the crop management. You can do monitoring, okay, condition, keep your eyes, watch on the crop, how crop is growing, but you cannot convert into a certain kind of management aspect. For management, farm management, we need to have a large constellation of numerous satellite like PlanetScope, QuickBird, World 3 which can generate almost daily satellite imagery with the partial resolution of less than 3 meter. Because our field size is very small, we want to monitor crop condition within the field for precision agriculture, then we need a very high partial resolution data with the less than 3 meter like PlanetScope, QuickBird, WorldView, and at the same time repeat cycle of daily. Because any crop water stress, if water stress of 2 or 3 days, it will lead to the more than 50% reduction in the wheat yield, particularly you can say in case of wheat crop. If water stress of 2 or 3 days during the crown root initiation, CRI stress 18 to 21 days after sowing, then there will be a 50% reduction in the crop yield. So we need to monitor this water stress condition every daily, then only we can use this information for making some corrective measures against the water stress. Because then similarly like other condition also, pest and disease also, 1 or 2 days, if Helicoverpa armigera pest like larva, it is there on the cotton, it can eat more than 10 cotton balls and it can almost destroy your cotton crop. So we need, if you want to monitor those kind of pest disease attack and all those things, we need a almost daily time step repeat cycle as well as very high resolution, so we can correctly identify what kind of pest, what kind of stress are there, what kind of crop condition is there, and accordingly we can prescribe kind of management to be performed by the farmers. Here you see there are satellites, drones. Apart from satellite, rapid eye, triple sat, sentinel, all we discuss, which are useful for crop growth monitoring, crop yield estimation, and leaf area index estimation, weed management. Nowadays there majority of people, government of India is pushing drone spraying as well as drone imaging for monitoring land record, crop condition, crop health, and also precision agriculture through its digital agriculture mission. So there are many farm producing organizations, FPO, they are implementing this drone technology, and they are drone Didi, so many drone pilot, even government is pushing drone Didi. So all our women, they are trained with the drone operation and they are earning livelihood at the same time using technology for monitoring agriculture, for drone spraying as well as imaging for the better agriculture livelihood as well as agriculture economic development. So here you can see there are different kind of attributes. Stress, we can monitor water stress with the drone, we can monitor pest and disease stress with the drone. So apart from satellites, nowadays drone technology is supporting high resolution satellite, because today we don't have a high resolution satellite with the daily repeat cycle. Some satellites are available but they are highly commercial, which farmers cannot afford. That is the biggest technical issue, limitation of using satellite technology. But drones are there, which is now evolving like anything by every state government pushing the drone based technology for the agriculture operation. So potential is vast for agriculture sector. Apart from the beginning from the crop area estimation, rate monitoring, drought assessment, horticulture crop assessment, cropping system analysis, command area, irrigation command area mapping, monitoring, soil mapping, pest and disease detection, inland fishery means aquaculture, inland aquaculture, and so on. So, but agriculture sector, India is one of the four nation which has adopted making use of space technology to generate crop production statistic and providing input to the sustainable agriculture. So we are operationally using satellites for monitoring crop area, crop condition, and assessing crop production prospect at district level, and finally making certain informed decision related to the import export, minimum support price, identification of cold storage, food processing power, demand gap analysis, and so on. There are different kind of satellites which are operating on biophysical, hydrological variable. Certain satellite give hydrological variable. There are satellites which gives mainly weather related information, radiation, temperature, humidity profile, cloud properties. So all has got immense role, particularly in agriculture sector. Now where you see, this is a way beginning from the growing season. This is a suppose rice season. Before in the June, when before planting, we require information about the weather forecast, how much rainfall will be there. Based on rainfall, we can start land preparation. Farmer can start land preparation. That weather forecast, improving weather forecast also require information. Improved weather forecast can be achieved with the assimilation of the satellite based observation. So today our IIM India Meteorological Department with the help of space agency, mainly our ISRO, there are many satellites which give a key information like cloud precipitation, water content, radiation, rainfall, which is more temporal and also which is more accurate to assimilate in the climate model or numerical weather prediction model to get better weather forecast. Once we improve weather forecast on a short term, maybe 3 or 4 days, then that will be useful to get information about how much rainfall is likely to be occur, which will be useful to the farmer for making decision related to the land preparation and starting sowing of their crop. Then initial soil moisture. Then comes next is a soil moisture. How much wet his farm is wet, a soil moisture is there in the field. Based on this, farmer can decide whether he has to sow his crop or not. Because if he sow crop with the little moisture, less than 10%, then there is a more chances of his not emergence of the seedlings. Seeds will not emerge. Seedling will not emerge when moisture is less. If he is satisfied that there are more than 15 to 20% moisture is there in the soil, then he can sow his seed so that seedling will emerge and he can last almost 7 to 8 days. Then next shower will come, it will regrow. Third, and this kind of soil moisture information we can get from passive microwave data as well as synthetic aperture radar. Then actual rainfall, which also you can get from the certain passive microwave rainfall and other satellite data. While during growing season, we want to monitor crop condition, crop growth stage, pest and disease, and all other weather, all information. So all this information, crop vigor, we can get from optical remote sensing like Resource 1, Resource 2, Landsat, Sentinel. Then pest and disease we can get from the different kind of drone as well as other imaging satellite like hyperspectral and all other satellites also multispectral we can use to certain extent. Then after even crop is harvested, also satellite remote sensing or satellites are helpful. Once harvested, we can use this satellite based crop production map along with the network, along with the some network analysis, GIS based analysis, we can identify which are the nearby cold storage facility can be constructed. So these perishable goods like tomato, potatoes and others which spoil in a couple of days can be stored, and so farmer can get better price whenever there is a good market price is available. So we can help farmer to locate cold storage facility nearby his area, so he can curtail cost as well as he can store his perishable commodities. Even after this, in the month of November, first week, there is some November end or something, there is a residual moisture. If there is good rainy season is there, then moisture is left. Maybe 15 or 20% moisture is there after harvesting of rice. Then always we can suggest farmer based on the moisture condition map available from the satellite. We can always tell farmer to go for another short duration crop like chickpea. So farmer can get another crop on residual soil moisture, and he can increase his farming income. So satellite are helpful to the farmer beginning of the growing season to even after end harvest, and even after harvest it can also help farmer to decide whether he has got certain possibility of growing third crops. So first, one of the most significant applications is mainly crop acreage and crop identification. So that next lecture, mainly it will be taught. But major application here, every crop, whether it is a tomato, chilies, wheat, sugarcane, cotton, mustard, different kind of crops has got different amount of energy being reflected and absorbed, which is called spectral signature. So different crop has got different unique spectral signature, and that helps to detect particular crop in the satellite imagery. It is not only the single date spectral, different variation in the reflectors across different spectral band, but sometimes we require more than 2 or 3 dates, multi-date satellite data to understand the phenological calendar, and based on the crop sown and crop harvest and maximum growth stage when it attains, based on that certain decision rule are made to classify different kind of crops, because every crop doesn't mature at the same time. Some mature early, some mature late. So based on those kind of farming agriculture phenological aspect of the different crops, we can ascertain different kind of crops which are grown or practiced in a particular region. You see, for crop type identification, mainly we are concerning with the classifying all crops from each other, but acreage estimation, it is concerned with only few target crops. So crop type means we can able to identify different crops which are grown in a particular district. So it is a highly challenging task, more complex, but acreage estimation easily we can do, because here if our interest is to get acreage of the particular crop like wheat, then we need not to bother about accuracy of other crops. We are mainly emphasizing on acreage estimation of the mainly wheat crop. Then crop type estimation, mainly this, how it can be done or what are the factors it depends. It depends on the canopy cover, leaf cover color, composition and phenology. Phenology means appearance of different growth stages in the life cycle of crop, or you can say timing of occurrence of different events within the life cycle of crop type due to abiotic factor like temperature or photoperiod. So this phenology, how different growth stages are appearing in the different time during the whole growing season, that helps to decide different kind of crop. Now here you see satellite data. If we have coarse resolution satellite data, earlier we are having WISP sensor 180 meter resolution. Today we are having MODIS 250 meter resolution. So at least India rice and wheat, which is the most staple crop, we can to certain extent get with the multi-date data. We can get this at least rice and wheat approximate coverage where they are grown. But with our advanced sweeps, 60-meter resolution on resource set, it can give information about rice and other wheat and other crop, wheat crop mainly in Haryana, Punjab. We can monitor, we can have good acreage estimation with the advanced sweeps also in Haryana, Punjab, because Haryana, Punjab there are big patches are there. But same cannot be used for the other state like Maharashtra, Gujarat, where okay multiple crop region is there. But in district level, least 3 24-meter resolution, this is ideal for the district level crop type mapping. Then mandal level, 6-meter, least 4 kind of satellite which are useful, and for reset, okay, here okay in during rice season also we can use reset also. And if village level or cadastral level mapping, nowadays there are cartosat, there are many even planet scope, world view, quick bird, high resolution commercial satellite available. Those can be used for field level crop type mapping as well as field level crop assessment. India we are having okay OCM, which is 360-meter resolution to today 5.8-meter resolution least 4 data. So the wide range of satellite data available to map different kind of crop across length and breadth of India. Another part of this satellite means imaging technology, that is a UAV. UAV is nothing but unmanned aerial vehicle. This technology is equipped with different kind of sensor, lidar, multispectral, thermal, hyperspectral, all facilitate high resolution data to get information of water body, vegetation and other feature. UAV it is mainly useful for detecting different kind of soil characteristic, crop characteristic and stress. Here you can see it is useful for agriculture field soil analysis, wildlife spread, widespread seed planting, crop health monitoring, spraying of input, irrigation monitoring, crop damage assessment and livestock tracking. So drone is useful for wide range of activity in agriculture sector. So these can be done imaging of the imaging with the drone, either multispectral or thermal, can help you to detect water stress, pest disease stress, and finally you can based on this variable trace what you can diagnose with the UAV based imaging. Then it is useful to generate a recommendation, generate a signal, prescription management strategy for the farmer, where to irrigate, when to irrigate and how much to irrigate. Limitation mainly okay in with respect to farmer, bigger challenge is the remote sensing is limited access available to high quality data. Like okay for farm management, we require very high partial resolution with the and the order of you can say less than 3 meter and almost daily repeat cycle. These kind of data are today not available freely. They are available at certain cost by certain private companies, commercial companies like PlanetScope and so on. So they are not directly nowadays used for the farmer management, but farmer cannot afford this kind of data. Another interpretation and skill, like okay understanding and interpreting this satellite imagery is a challenge, because these data are very complex. Even when we are having SAR data, synthetic aperture data, it depends on many parameter, like okay sensor parameter as well as surface parameter. Sensor parameter, elevation, angle, this polarization, all those difficult to understand by the many stakeholder, even including farmer and extensionists, because once they want to interpret image for different angle is suitable for different kind of crop, different kind of activity. So it is very difficult for the farmer or extensionist to understand and get expertise to interpret those complex satellite imagery. Cloud cover. Cloud cover is a okay major obstacle, because we won't get satellite data, particularly optical satellite data, whenever there is a cloud cover, because it is obstacle to the sun rays. So if we do not get sunlight, we do not get also reflected radiation map correctly. Technical limitation. Some remote sensing technology itself has got certain limitation, technical issue. Like that, okay, as I said, optical remote sensing, which use with the natural light, cannot penetrate through the cloud and cannot give you information about the certain agriculture information during the cloudy season. That is a limitation of optical remote sensing. But now it is overcome with the active microwave remote sensing. But there are certain sensors which are not sensitive to the certain phenomena, like okay, soil moisture or high biomass crop. Even though active remote sensing sensor, they are not sensitive to the high biomass crop because they are not having more penetration capability to get the soil moisture. So unless until you are having a L band, then only you can detect soil moisture with the sufficient depth, and also it can penetrate through the vegetation and give you a information about biomass. So certain sensor are okay useful for crop mapping and all those things, but quantification of like okay certain information which is vital for agriculture planning and monitoring is not possible due to some non availability of specific sensor which has got more sensitivity to vegetation structure, biomass, soil moisture and underneath surface. So this is all about okay how we are going to use this all technology for future agriculture by integrating artificial intelligence, weather forecasting, data analytics, remote sensing to map and monitor to achieve digital agriculture solution in future time. Thank you all. Hello. Now we will start interactive session. So there is a one question from Praveen, who is asking whether top of the reflectance or surface reflectance, which is better. It is surface reflectance is always better. Top of atmosphere reflectance means it is calculated without correcting the atmospheric effect. So if there is atmospheric water vapor, so it will have without haze correction or atmospheric effect. So it may not be ideally suited for discriminate quantification of production, leaf area index, or any quantitative attributes. Always it is advised to make use of surface reflectors, so you can get better estimate of different vegetation index, and you can relate them with the canopy cover, biomass, and yield. Then there is a one Ruhi, who is asking, there are all these data, satellite data products, are they available? How to get it? So these satellite data, some of them now it is list 3, list 4, all are made free through our Bhuvan satellite Bhuvan platform at our National Remote Sensing Center, Hyderabad, ISRO. So list 3, list 4, advanced list, all these nowadays it is made free. So you can use, download and make use and do certain study for developing crop yield model or agriculture sector. So this data is free. Yeah, likewise Sentinel 1, 2, Modi's, all data available freely from some certain kind of data portal. Like Sentinel is available from one Copernicus, and then Terra Modi's for land data process from NASA. So there are website portals are there. You just search those data, you will get freely product, raw reflectance, as well as raw spectral band in raw data. So all you will get freely and make use for the agriculture sector. Then there is one Moni, Mini Moni, who is asking, Mini Moni, who is asking what is the role of remote sensing in crop insurance scheme, mainly Pradhan Mantri Fasal Bima Yojana in India. So Pradhan Mantri Fasal Bima Yojana, which was introduced to provide correct compensation claim for to the farmer in view of natural hazard and natural calamity, which is destroying farm produce or crops. So whenever there is a drought, flood damage, or you can say heat, pest and disease, it leads to the crop loss. So accurate crop loss estimation, we need to have a space technology, particularly crop yield estimation. So if we make crop yield estimation before and after, crop loss assessment can be done. So that crop loss assessment we can do accurately with the space based data, whether it is a active remote sensing data or optical remote sensing data. So today there are many satellites like PlanetScope, Sentinel, and even our list 4. These all satellites are useful for making crop loss assessment. Apart from this, there are drone. Nowadays drone is available with the satellite imagery, with the some imagery. So drone are becoming more useful for the understanding how much crop loss is there and crop yield estimation. Finally it helps to get better crop loss assessment and convert it into a crop insurance index. Then Ajay Bora, who is asking what practice can improve soil organic matter and overall soil health. For soil organic matter and overall soil health, we need to have a conservation agriculture. Conservation agriculture means that comprise of agroforestry, that comprise of cover crops, that comprise of addition of humus. There are many conservative agriculture practice, zero tillage. These are all conservation agriculture practice, which is a now urgent need to implement by the farmer, because we all are facing a great challenge of fighting against the climate change, and conservative agriculture is only the option left to curb this greenhouse gas emission and finally make our agriculture sustainable and profitable. Question another, okay, Rushika Sharma, who is asking what skill or tools should be student master to work in a agriculture agri data analytics with ISRO or similar organization. Mainly this all my advice to all this youngster, that you all should shall make certain kind of improvement with the data analytical skill. You should use Python programming, R programming, or learn some kind of programming which is now freely available. Tools are there. So these are the some data learning or some programming skill that will help you to understand how best you can utilize satellite data and make faster processing with this kind of tool, like okay, data analytics like Python programming, or you can say artificial AI, ML technique, machine learning technique. Those are the things. But software doesn't matter nowadays. All this image processing software available freely. You can use IIRS, you can use okay many software which are nowadays okay available freely. So you can use download, take satellite imagery from our NRSC center from Bhuvan and try to make use of satellite imagery for making certain kind of natural resource management or water management related application and help farmers. Aditi Rao, who is asking, okay. Then there is a okay Anshul Singh, who is asking how are AI ML model being integrated with IIRS data for predictive agriculture. This particular course, remote sensing data analytics for crop production forecasting, which covers with the advanced data analytics. So there will be a lecture specialized for AI ML in its application in the predictive analytics of the crop yield and other things. So we may use different kind of satellites along with the machine learning algorithm and other simulation algorithm to predict crop yield and also crop area and other things. So that will be a special session during these 5 days. So you can have that learning. Then there is a Sivanand who is asking for deep analysis of particular portion of agriculture field. Is the drone sensing or satellite sensing is good for okay in depth within field variability analysis of the particular field. Always okay drone is advised, but at the time having drone flight regularly every weekly is not possible. It will be highly expensive and time consuming. So you can have drone imaging one or twice in a season, but you cannot monitor crop condition, crop growth regularly at on a weekly time step with the drone. Then it becomes very expensive solution. So always advise to integrate high resolution imagery from the drone with the satellite based frequent image on a weekly time scale to come out with the achievable or amicable solution. So both data need to be integrated, drone and satellite. Then role of AI, okay, everybody know AI has got biggest potential for predictive analytics, moisture monitoring, sensing, disease prediction, drought prediction, and also crop yield prediction. All through it is done through AI, and there is simulation modeling and machine learning is a part of AI. So there will be a session on AI ML and advanced technique in these 5 days for predictive analytics of the crop yield and production forecasting. So today we had this brief session on overview. Then okay, one pasta man, how do satellite data and drone data compare in terms of resolution and usefulness? So satellite is very much advantageous because it has got large area coverage, so it can cover large area and you can monitor on a regional scale. Drone, they are very good for the in-depth analysis for the small patches, field or small urban areas. So they are mainly used as a, you can say, validating tools or ground truth. Because drone you cannot, it become very expensive if you are doing for the whole district or whole state, and at the same time individual farmer cannot afford drone. So drone is only for, okay, maybe okay, you can use for imaging, for precision agriculture, those okay which are having a some outside support of cooperative sector or some private sector support is there with respect to the drone purchase of drone sensor and so on. Otherwise for farmer it is a costly affair to get drone, as well as drone which cost also 2-3 lakhs, and also imaging camera costs also 10 lakhs. So it will be very difficult for farmers to purchase and procure for an individual field. Then Praveen Joshi, can you give an overview and highlight of today's session now? So this is a highlight of this session is mainly fundamental, how best we can make use of remote sensing for agriculture sector, what are the different kind of sensor available to support monitoring of agriculture sector, and what are the future potential of satellite remote sensing and drone imaging in the agriculture sector. Can we predict the crop yield using Landsat satellite data without using GE? Of course, we can make okay with the Landsat prediction of the crop yield through certain kind of crop yield modeling. So there are many effort has been done in the past to map and monitor crop type as well as yield estimate with the Landsat data. So maybe okay, in time permits in the crop production potential, I'll show you one example with the Landsat and also Sentinel yield estimation. In the last day we will have one session to make use of UAV and crop simulation model for yield estimation. There will be also next tomorrow and day after tomorrow we will have different approaches with the satellite, how best we can make yield estimation with the satellite and different approaches. Job opportunity in Vijay Prasad, who is asking what is the job opportunity in remote sensing data of agriculture. As I said in my lecture, agriculture is the major user of the satellite data. More than 70% of all data which is being produced worldwide with the all satellites are being used for agriculture sector only. Because today major focus of space technology is in agriculture. Because agriculture is undergoing digital transformation, whether it is crop insurance, digital registry of the land record, or you can say water management, or you can say smart agriculture, tracking of the livestock, anything, identifying cold storage facility, food processing park, any e-market, every aspect of agriculture sector requires satellite remote sensing. So today satellite, there are so many opportunities, there are so many agri-tech startup which are using satellite, and they are recruiting all youngsters who are specialized in this data analytics for the achieving certain goal of agriculture economy. So agriculture sector huge opportunity is there. Those who are having a knowledge or having some tool and technique know-how about the data analytics, it's used for monitoring agriculture. There are any case studies of any article example of GIS used in crop production practically. GIS is integration of satellite data with the weather observation and other things. So there is a one agroclimatic yield index, or also you can say a biomass production model which integrate satellite imagery, weather observation, soil observation, all those in a GIS database to make yield estimation. So day after tomorrow I will show you the GIS based integrated model for yield estimation. So there are many examples where people have made use of weather data, soil data, and satellite imagery data, all integrated in the GIS environment for making crop production estimate. Nutrient management, Abhishek, who is asking precise nutrient management, which emerging technology offer more significant opportunity. Yes, of course, This precise application of nutrient is very much required for precision agriculture. So if we can do certain kind of technology like drone with the good imaging of the can soil nitrogen and soil organic matter, and based on that we can apply when and where it is required, nitrogen fertilizer is required, so and then we can reduce fertilizer requirement, as well as we can have little lesser nitrate pollution in the groundwater. So it is precise nutrient management is vital. Then okay, how to predict, okay, Subhaj is there who is asking how to predict crop water depth in the field using remote sensing. Crop water depth is nothing but it is a crop water requirement. So we can estimate with the help of satellite remote sensing, which is available data green vegetation index, multiply with the reference evapotranspiration. Means with reference evapotranspiration we can estimate from the geostationary or weather satellite data, and crop vegetation index or crop coefficient we can estimate from the optical remote sensing. We can monitor on a weekly time scale how much crop water requirement depth, and finally we can decide some irrigation schedule also. Is this Astro who is asking, is this course profitable for computer science student who has domain course in data science? Of course, those who are very good in data science and data analyst, they are on the forefront, because they can make use of this, okay, decision making faster. They can use satellite data all available in the different clouds like Google, Earth Engine, all those things. They can immediately process data and make in a analysis ready data and bring into the solution format, which is directly usable by the farmer. Nowadays it is a requirement of the data analytics to make all these data, product and services available in a usable format. So there is a big scope for the data analytics scientists and data analyst of remote sensing. So okay, one Vijay Prasad was asking, sensor which penetrate cloud giving will have impact if the reflectance also impact by the cloud is impact reflectance illumination. Sensor, because these are those sensor, okay, like okay, radar sensor which are not affected by the cloud. They are directly penetrate through cloud, so backscatter radiation it is not affected by the cloud. But other than that, reflectors, because sunlight energy it is highly reflected, cloud contaminated, so we cannot get correct image. Then Harsh Dasana who is asking how can remote sensing help small scale farmer. In India, small scale farmer they are okay, mainly okay, smallholder farmer. It is now, as of now, we are not having a kind of satellite data, but we are developing a technology like okay, crop insurance. Small farmer also we can make use of PlanetScope or high resolution satellite data to make watershed prioritization, watershed conservation measures, and also certain okay, precise agriculture. So smallholder farmer system, okay, if we monitor and ask them to any damage assessment, crop loss assessment, all those if we provide them in a ready product, so government authority can use those product and make right kind of compensation to those small farmer. So small farmer they are really going to get benefited by better conservation, innovative agriculture, and also sustainable agriculture practice can be developed with the use of geospatial technology. Okay, so these are all things. There are so many satellite data questions are there. Those who are specifically questions are there, they are advised to directly contact to my email address, or you can give this to this forum, and this all question I will reply in the due course of time in future, next 5 days. So I will reply all these questions to their email. So write with your email to my email address nrpatel@irs.gov.in. If you have specific question, I will be happy to reply all of you. Okay, thank you all.